This is an instructional video on how to graph systems of equations. So when we graph systems of equations, we got a couple of steps that we have to work on. The first step is making sure each equation, you're going to end up with 2, is in slope-intercept form. That's the y equals mx plus b form. Step 2 is to identify the slope, that's the rate of change, letter M. Step 3 is to identify the y-intercept. That's the initial value. That's our b equals. Once you've identified your slope and your y-intercept, m and b, we are going to graph the y-intercept on the y-axis. We use the slope, that's the m equals, to go up or down, and then always right. Up represents positive, down represents negative. Once you've graphed the two equations, you'll end up with a couple of different possibilities. If the lines intersect, meaning they cross, that means it's a one solution answer. You have to write down the point they cross at. If the lines are parallel, that means they do not cross. That's going to be a no solution. And if the lines are the same, meaning there's only one line on the graph, that's going to represent an infinite solution. So we start out by identifying and making sure our equation is in the y equals mx plus b form. M represents the slope, the rate of change. B represents the y-intercept. Which is the initial value. So looking at our two equations, y equals negative 1/2 x plus 3. M is going to be our negative 1/2. The 1/2 and the x go together. The plus b is at the end. So our b value is 3. Now when we graph it, we graph the b value 3 first on the y-axis, which runs up and down. So we graph 3. My slope, m, is a negative 1/2. Negative tells us to go down. So we're going to go down 1 and right 2. So starting at our point 3 that we graphed, we're going to go down 1 and right 2. Down 1 and right 2. Down 1, right 2, all the way to the edge of the graph. Once you get to the edge, then we go the opposite direction. We start back at 3, we go up 1 and over 2. continuing our pattern and following our line. Once our line goes all the way across the graph, we can go ahead and connect our dots. Make sure you go back and erase your counting steps. When you have a finalized answer, you can only have your points in your line. Now, for your second equation, y equals 5, the mx is missing. There's no x variable, so that means there's no slope. It represents letter M. Our b value is the number there, the positive 5. We graph the b value first, the rate of the initial value, the y-intercept, so we put a point at 5. Our slope, our rate of change, is 0, meaning we cannot go up or down. It is a straight horizontal line, straight across. I can see that these two lines intersect. They intersect at this point here, meaning we have a one solution answer, and our answer is going to be -4 and 5. -4 and 5. For this problem, our first step is to make sure our equations are in slope-intercept form, that they match the pattern y equals mx plus b, and both of these equations do. Both y values are all by themselves on the left-hand side of the equal sign. Our second step is to identify our slope, the m value. In the first equation, our m value is going to be 1/3. The 1/3 x is side by side. In the second equation, we have a -x. In math, when nothing is written there, we understand that that is an understood 1, so it's going to be a -1x. Our third step is to identify our b value, which represents the y-intercept. In the first equation, we have a -2. We do take that minus sign to represent a -2. And in the second equation, we have a +2. Now, when it comes to graphing the equations, starting with the first equation, we graph the b value first, -2, on the y-axis. Then we can graph our slope. It's a +1/3, so that tells me that we're going to go up and then always to the right. Up 1 and over 3. Up 1 and over 3. All the way to the edge. It might go off the graph a little bit. That's okay. Once you get to the edge, you can go the opposite direction, down 1 and over 3. Again, if it goes off the graph, that's okay. And connect your dots. Make sure you go back and erase your counting lines, as the only thing that can be in your answer are your points and then your connected dots. Now for the second equation, again, we graph the b value first, which is a +2 on the y-axis. And we're going to graph a -1, which means we're going to go down. When you have a whole number, you have to write it as a fraction over 1. Your denominator for whole numbers is always 1. So we're going to go down 1 and right 1, down 1 and right 1, all the way across, down 1 and right 1. Once we get to the edge, we can go the opposite direction, up 1 and over 1, following our pattern until we reach both edges. And we can go ahead and connect our dots. Make sure you go back and erase your counting lines if you drew any. Now we can see that these two lines intersect, they cross, so this means we have a one solution answer, and they cross at 3, -1. That's where that point is located. For this problem, again, we want to make sure both of our equations are in slope-intercept form, so they match the y equals mx plus b equation. Both of these equations do. The y value is by itself on the left-hand side. The second step and the third step are to identify the m equals value, which represents the slope, and our b equals value that represents the y-intercept. In the first problem, our m value, our slope, is represented by this 1/2 x. Our b value is not there. There is no other number, so that is represented as a 0, a +0 at the end. When we graph that equation, we start by graphing 0, which is here at the middle. We graph a positive 1/2, which means we're going to go up and then to the right. So up 1 and right 2. Following that pattern, up 1 and right 2 all the way to the edge. Once we make it to the edge, we go the opposite direction, down 1 and over 2. And then connecting our dots at the end. Make sure you go back and erase your counting lines. Your answer can only consist of your plotted points and then your connected dots. For our second equation, our m value is again represented by the 1/2 x, and our b value is represented by the +3. We graph the b value, the y-intercept first, so we put a point at 3 on the y-axis. Our slope, our m value, is a +1/2, which means we're going to go up. You should notice that the slopes are the same. They are both +1/2. We are going to go up 1 and right 2, following that pattern until we reach the edge. Once we reach the edge, we're going to go the opposite direction, down 1 and over 2, connecting our dots at the end. Go back and erase any counting lines that you made, leaving only your points and the connected dots. We should notice that these lines do not intersect, and so this represents a no solution. When they have the same slope, it's always going to be a no solution problem. So our first step for this problem is to make sure both equations are in the y equals mx plus b form. The top equation it's already y equals 6x plus 3. The bottom equation is not. It is 6x equals y minus 3. So we need to take that equation and we need to rewrite it. We need to get what is ever with the y by itself. So in this case we have y minus 3. So we're going to do the opposite. We're going to do a plus 3 and move it away from the y value. So we now have 6x plus 3 equals y. Our equation has changed. If that confuses you, you can flip it backwards and rewrite it as y equals 6x plus 3. It does mean the same thing. Now that our equation has the y by itself, now we can go ahead and solve it. So again, our step is to identify our m value, our slope. In this case, it is a 6. And then our b value is a positive 3, our y-intercept. We start by graphing the y-intercept, the b value, first. So we put a point at positive 3 on the y-axis. Our m value is a positive 6, meaning we're going to go up. And then to the right, we go 1, because when we have a whole number, we always go to the right-hand side, and our fraction is written over 1. Now, I cannot go up 6. I go up 3. I could extend it off the graph. It would put it about there. It's a little hard to guess. And so since we can't go that direction, we're going to do the opposite. I'm going to go down 6 and over 1. Connect my dots, Again, hard guess the top. And you can move on to your second equation. For our second equation, we're looking at what we've created. Our m value is going to be this 6. And our b value is going to be the plus 3 at the end. When we graph the b value first. So we have we start at a positive 3, starting in the same location. And we have the same slope, up 6 and right 1. We can't go up 6 and right 1, we run out of room, so we go down 6 and over 1, and we end up with the same line. And so when we have the same line, we end up with an infinite solution. What you should have noticed is that we had the same equation. Y equals 6x plus 3 for the first equation, y equals 6x plus 3 for the second equation. The same equation represents an infinite solution. Our first step is to make sure our equation is written in y equals mx plus b form. The top equation is not, that y value is not by itself. We have to move everything that is keeping the y from being by itself. We start with the x value, we move a minus x over and make it a plus x. So now we have x and we have a minus 4. The y is still not by itself. The 4 and the y side by side means multiply, so we do the opposite, we divide. When we divide, the number in front of the x is an understood 1. There's nothing written there, so it's a 1. 1 divided by 4 gives us 1/4. 4 divided by 4 gives us 1. Our new equation is going to be y equals 1/4 x minus 1. When it comes time to identify our m value, the slope, we are looking at the 1/4 x because m and x go side by side. And our b value is going to be the minus 1 at the end. When we graph the equation, we graph the b value first, so a negative 1 on the y-axis. And then we graph a positive 1/4. Positive is up, and so we're going to go up 1 and right 4, all the way to the edge. Once you get to the edge, we go the opposite direction, down 1 and over 4. Again, all the way to the edge, connecting your dots at the end. For the second equation, our slope, the m value, is 1/2 because 1/2 x and mx go together. And our b value is going to be our minus 2. When we graph it, we graph the y-intercept, the b value first, so we put a point at negative 2. When we graph our slope, we graph a positive 1/2, so we're going to go up 1 and right 2. Connecting our dots along the way. We can see that these two lines intersect, and so this is a one solution graph, and they cross at the point 4, 0. Our first step is to make sure that our equations are in y equals mx plus b form, slope-intercept form. Looking at these two equations, they both are correct because the y equals is on the left-hand side and everything else is on the right-hand side. We can go ahead and identify our slope, the m value, which is going to be 3 because 3x goes together. And our b value is going to be the minus 2. We start by graphing the b value first, so we put a point at negative 2 on the graph on the y-axis. Then we graph our slope. It is a positive 3, so that tells us that we're going to go up. And then we write it as a fraction 3 over 1. so we're going to go right 1. Up 3 and right 1, putting our points all the way to the edge. Once we get to the edge, we can go the opposite direction, and then connecting our dots at the end. For the second equation, our slope, again, is a 3, and our b value is a positive 3. We graph the b value first, so we graph positive 3 on the y-axis. Our slope m is a positive 3 as well, so we're going to go up 3 and right 1. We write it as a fraction with the denominator as 1. We go up 3 and over 1, going off the graph just a little bit, and then down 3 and over 1, because once we reach the edge, we have to go the opposite direction. And then we connect our dots at the end. These lines do not intersect. This is a no solution graph. You should have realized that immediately because we had the same slope, which represents a no solution. Both slopes in this equation were positive 3s. Our first step is to make sure that the equation is in y equals mx plus b form. The first equation is the y value is by itself on the left-hand side of the equal sign, but the second equation is not. We have to take the 4y minus x equals negative 4 and rewrite it. To get the y by itself, we start by moving the minus x. By doing the opposite, we do a plus x. So we have the plus x and we have a minus 4. The y is still not by itself. The 4 and the y together means multiply. We do the opposite, we divide. There's nothing written in front of that x. We know it's an understood 1. 1 divided by 4 is 4, so that's a 1/4 x. 4 divided by 4 is 1. Our new equation is y equals 1/4 x minus 1. Looking at these two equations, the top one, y equals 1/4 x minus 1, and the bottom equation, y equals 1/4 x minus 1, we know that they are the same equation. When you have the same equation, you are going to have an infinite solution. We can tell that without even graphing it. However, you still have to graph your answer. So we start by identifying our slope, the m value, 1/4, and our b value, negative 1. We graph our b value, negative 1, on the y-axis because it's the y-intercept. We have a positive 1/4, so that tells me that we are going to go up 1 and to the right 4, all the way to the edge, and then connect our dots at the end. For the second equation, our slope, again, is the 1/4 x, and our b value is the minus 1. When we graph it, we graph the minus 1 first because it's our y-intercept, and we graph it on the y-axis. Our slope is a positive 1/4, meaning we go up 1 and right 4. And so when we place our points and draw our line, it ends up being the same line. The same line represents an infinite solution.